So welcome everybody to this latest revision video on 162 Maths, and in this video we'll be covering the AQA GCSE Maths 2022 Higher Paper 2 Advanced Notice information relating to the statistics and probability section. Now, as always, there is a link to the questions in the description below for you to have an attempt at either before watching this video or while watching this video and going through the answers. So before we get started on some example questions, let's just have a look at the advanced information given for paper 2 regarding the stats and probability section. Now, it is important, again, I reiterate that with this advanced notice, don't think that there's going to be a unique question related to each individual topic that has been mentioned. There is a lot of mixture that can be done. So for example, a pie chart question could be linked to a ratio, it could be linked to equations, it could be linked to any other topic that's mentioned in the number, geometry and measure, and algebra and ratio sections. So as well as it's important that you understand each individual topic, make sure you're able to spot and use areas from other topics to be able to answer certain questions. So looking at the statistics part, the first one, which is estimations from a sample. For this, I would recommend that you know how to make a sample and how to calculate values for what's going to be contained in the sample, and also just basic information about how you would collect a sample as well. For pie charts, you need to be able to draw a pie chart, know how to work out the angles, but also how to read information from a pie chart and also work backwards. So when you're given a pie chart, can you then work out the frequencies? And again, pie chart questions in the past have been linked with other areas of algebra, number, ratios and proportion. When it works out the mean, it's not just a case of knowing what the mean is, it's about working to calculate the mean from a table or from a string of data, from a list of data, and also to be able to work backwards. So if you're given the mean, can you work out what one of the missing values that they've calculated the mean from? When it comes to probability, relative frequency, you just need to be able to know how to calculate relative frequency, what it is in terms of using experimental data, and also how to use the relative frequency to find the frequencies as well. And looking at expected values, I would say those two topics in the first two of relative frequency and expected values are kind of linked between the two. Notation, that can come across with regards to Venn diagrams, tree diagrams. So just be wary of using correct notation of probabilities. So, and just be mindful, and hopefully the example questions that we go through will hopefully cover the basis of these. So let's get started on some revision questions. Now again, just a simple reminder that if you're wanting to have a copy of these questions or have an attempt at these questions before watching the video and we go through the answers, then just simply click on the link in the description below. So looking at question 1, it says that a fishing lake contains thousands of fish. The fish are either carp, bream or roach. 10 fish are caught. The table shows some of the results. And here we've got the frequency and we've got the relative frequency. And what this question is asking us to do for part A is to complete the table. So for this, what we need to do first is work out what the relative frequencies is going to be. So looking at this box here, then to work with that one first, all I need to do is do the frequency divided by the total, which is going to be 4 divided by 10, which is 0.4. Then with the frequency of the bream, then for this, all I need to do is multiply the total, which is 10, by the relative frequency, which is 0.1, and that gives me an answer of 1. And then if I then work out for this box, well, all of those need to add up to 10, because there are 10 fish. So this therefore is going to be equal 5, and that therefore means that this relative frequency is going to be 5 divided by 10, which is 0.5. It then says that the owner uses results to estimate the proportion of carp in the lakes. How can she make her estimate more reliable? Well, to make things more reliable, what you need is a higher total. So in other words, what she needs to do is catch more fish. Now there may be other answers you could give that to get you the single mark, and again just have a look at the mark scheme in the description below. So moving on to question 2, it says Garage A sold 4,960 vehicles. The garage takes a sample of customers stratified by the type of vehicle sold. Some information about the sample is shown, and part A for 3 marks is asking us to complete the table. So first things first, what we need to do is work out how much of the total number is being selected for the sample. So for this, if I do 2520 divided by 126, I get that it's 20. So to get from here to here, I need to divide by 20, which therefore means that if I want to go in the opposite direction, I need to multiply by 20. So for example, for the people carriers, I need to multiply 44 by 22, which gives me 880. For the vans, what I need to do for this value here is basically take away from 4,960, take away 2520, take away 880, and that leaves me with 1560. And then if I then divide that number by 20, I get a total of 78. And then for the total, all I need to do is add these three numbers up, and I get an answer of 248. Alternatively, I could have just divided 4,960 by 20. Question B, it says Garage B sold 3,790 vehicles to 3 sig fig, and it says write down the maximum number possible sold by Garage B. Now the third significant figure is a 10, so if I halve that, which gives me 5, so basically what I'm doing to 3,790, I'm going to add and subtract 5. It's always half of what the units represent. So here the minimum value is going to be 3785, and the maximum value is going to be 3795. Then moving on to question 3, it says that a sample are taken from production line. The number of faulty items is shown. Which sample has the biggest proportion of faulty items? And it says you must show your working out. So for this, what I need to do is if I label sample A, and let's work out the portion of this. Now to work out the portion, it's just going to be 42 divided by the grand total, which in this case is 300 for sample A. So that gives me 0.14. I then do the exact same for sample B, and that's going to be 33 divided by 250. That gives me a value of 0.3132, and sample C is going to be 48 divided by 400, which gives me 0.12. So which of these has a higher proportion? Well, it's going to be sample A. Then moving on to question 4, it says that a factory makes kettles. 4 samples of kettles are tested for faults. Each sample has a size of 200. Here are the relative frequencies of faulty kettles in the sample. And the question is asking us to work out the range of the number of faulty kettles in the 4 samples. So here in terms of sample P, what I need to do here is multiply the relative frequency by the sample size. So here for P it's going to be 200 times 0.03, which gives me an answer of 6. Then for Q it's going to be 200 times 0.035, which gives me an answer of 7. Then for R it's going to be 200 times 0.015, which is 3. And for S it's going to be 200 times 0.01, which gives me an answer of 2. So here the range is going to be the biggest frequency, which is 7, take away the smallest frequency, which is 2, giving me an answer of 5. Then moving on to question 5, it says the result of a game is win, lose or draw. After 80 games, the relative frequency of the result of a win is 0.4. The relative frequency of the result of a loss is 0.25. How many games had the result of a draw? So here in terms of a win, again multiply the relative frequency by the grand total. So I'd multiply that by 80 and I get 32. For the loss, it's going to be 0.25 times 80, which is 20. So in terms of drawing, all I need to do is do 80, take away 32, take away 20, which gives me an answer of 28. Then moving on to question 6, which looks at pie charts. It says the pie chart shows the proportion of males and female teachers in 15,074 schools. The mean number of teachers per school is 13.7, and it says work out the total number of female teachers in the school, and we want to give our answer to two significant figures. So here the total number of teachers is going to equal 15,074 multiplied by the average number, so it's going to be times 13.7, and that gives me an answer of 206,513.8. So from this, what I then want to do is work out the proportion of female teachers. Now if I use the pie chart, well, female teachers is therefore going to be 310 degrees, so it's going to be 310 over 360. So then to work out the total number of female teachers, so the total number of female teachers is going to be the proportion, which is 310 divided by 360, which I could simplify. I'm just going to leave it as it is, multiplied by the total number of teachers, which is 206,513.8. And if I type that into my calculator, I get an answer of 177,831.3278. Now what I want to do is then round this number up to, actually I've missed out a number, that should be a 1 there. And let me just write that number a little bit clearer. So what I should have is 177,831.3278. Then round this number up to 2 sig fig, so that's going to be 180,000, and that's to 2 sig fig. And that was a 5-mark question. So moving on to question 7, it says that there are 36 men in a running club. The pie chart shows information about their favourite races, and the questions is saying there are 20 women in the running club. Here is some information about their favourite races. The same proportion of women prefer the half marathon as men. The same number of women prefer the 5k as men, and equal numbers of women prefer the 10k race and the marathon. It says use this information to fully label a pie chart and show the favourite races for women. So what we need to do is complete this pie chart. So this one is quite a complex, not a complex question, but quite a fiddly question, even though it's only worth 4 marks. So let's go about doing this. So looking at this information, and let me just zoom out so we can actually see all of this in its entirety. Okay, so from this, let's first of all, we know that the total number of women equals 20. So then from this same information, what we need to do first is, in terms of the half marathon, it says that the same proportion of men are the same proportion for women. So here, looking at the male pie chart, we've got a quarter. So a quarter of 20 is 5. So then if I then look at the next type of race, let's look at the 5k. So 5k. Now here it says that the same number of women prefer the 5k as men. So what I need to do is work out how many men like the 5k. So here it's going to be 70 degrees divided by 360, and if I multiply that by the total number of men, which was 36, I then get an answer of 7. So that means that for 7k, for the 5k, it's going to equal 7. So from this, how many women are left? Well, 20 minus 5 minus 7 is going to give me an answer of 8. So that means that in terms of the 2 races that are left, so I've got the marathon and I've got the 10k, that there are an equal number of women prefer the 10k than marathon. So if I've got 8 women left, if I halve that, I'm going to end up with 4 and 4. So using those numbers then from the pie chart, so if I then look at the race, and so I've got the marathon, I've got the half marathon, I've got the 10k, and I've got the 5k, and then I've got the frequency of those. So the marathon was 4, the 10k was 4, the half marathon was 5, and the 5k was 7. So from this, what I then need to do is work out the angle. Now the angle for a pie chart is the frequency divided by the total frequency multiplied by 360. So here, if I look at the angle, I'm going to do 4 divided by 20, because there's 20 in total, multiplied by 360, and that gives me an answer of 72 degrees. Then for the half marathon, that's going to be 5 over 20 times 360, and that gives me an angle of 90 degrees. Then for the 10k, well, that's going to be the same as the marathon, so that's going to be 72 degrees. And for the 5k, that's going to be 7 over 20 multiplied by 360, which gives me an angle of 126. So from this, what you should have, and again, make sure you are labeling these. So this is going to be the half marathon. Then for 126, let's just say for argument, I'm not doing this accurately, but I would say this length here is going to be the 5k, and then half of what's left is going to be the 10k and the marathon. So something along those lines, but again, make sure that you are using the correct and measuring the correct angles. And there we go for that particular question. So looking at question 8, says the number of goals scored by 20 players in a season is shown, and the question is asking us to work out an estimate of the mean number of goals per player and give your answer as a decimal. So for this, let's have a look. So first things first, we need to work out the midpoint. So the midpoint, we just add the upper and lower bound and divide it by 2. So here I'm going to end up with a midpoint of 2, a midpoint of 7, and a midpoint of 12. And then what I then need to do is to work out fx value, in which all I need to do is just multiply these numbers together. So here I'm going to end up with 12, 77, and 36. And then work out the total, which is 125. Then the estimated mean is going to be 125 divided by 20, which gives me an answer of 6.25. Then moving on to our next question. Question 9, it says, here is some information about the number of books read by a group of people in 2014. One of the frequencies is missing, and it says the midpoints are used to work out an estimate for the mean number of books read. The answer is 8.5. Work out the missing frequency. Now, a couple of ways in which you can do this. So for example, if I just create an fx column, so here I'm going to end up with, if I just call this frequency x, then this value here is going to be 32. This value here is going to be 7x. This value here is going to be 240, and this value here is going to be 170. So then to work out the estimated mean, it's the total frequency divided by, so the total of fx divided by the total frequency. So here what I've got is I've got 3046 plus x. And here what I'm going to end up with is, if I add up all of those numbers, I'm going to end up with 7x plus 442. So here the estimated mean is the total fx divided by fx, as total f rather, what we're doing there, total of f. So what this is, then the estimated mean is 8.5, and the total fx is 7x plus 442 divided by 4x plus 46. Now if I put that in brackets, what I'm then going to do is I'm going to take that to the other side. So what I end up with is 7x equals, or 7x plus 442, don't forget that, equals 8.5 bracket x plus 46. Then if I expand the brackets, I end up with 7x plus 442 equals 8.5x plus 8.5 times 46, which is 391. Then now I've got x's on both sides, so let's get x on one side, so let's take the 7x over to this other side and the 391 over to this side, and I end up with 1.5x equals 51. So then if I then divide by 1.5, I end up with x equals 34, and there is my final answer. Moving on to question 10, it says, so here we've got histograms. So it says the histogram represents the height of 90 firefighters, and the question says which of the 4 bars represents the greatest number of firefighters. So what you're looking for is basically which bar has the biggest area. So with this, what we're going to do is we're going to, first of all, let's have a look at the grouping. So we've got 170 to 175. I've got 175 to 185. I've got 185 to 190. And I've got 190 to 200. So then working out the areas of each of those bars. So again, I'm just going to multiply the height, which is measured in frequency density, and the height of the bar over the height in terms of the width of the actual rectangle. Very confusing. So here we've got 5 times 2, because obviously we've got 5 here and with a height of 2. So that gives me 10. Then with the second bar, I make that out to be about 3.8 by 10. So it's going to be 10 times 3.8, and that gives me 38. For the next bar, I've got 5 times, and I make that out to be 6. So let's go for 30. And for the next one, I've got 10 times with a height of 1.2, which is 12. So in terms of here, which bar represents the biggest area or the greatest number? Well, it's going to be 175 to 185. Now again, it is important because it does say you must show your working out, so you can't just simply say which one has got the biggest area, even though it's quite obvious from the histogram that the biggest bar, or the rectangle with the biggest area, is that second one. Moving on to the next one, it says calculate the estimate for the mean height. So for this, what I need to do is look at the midpoint. So let's get rid of the highlighter first. So I've got my groups. I've got 170. Actually, let's do that a little bit lower. So I've got the group. I need to work out the midpoint, and I've got the frequency. So from this, I've got the group of 170 to 175. So the midpoint is going to be 172.5. For the next one, I've got 175 to 185. So the midpoint is going to be 180. The next group is 185 to 190. So the midpoint is 187.5. And the next group is 190 to 200, which is the midpoint is 195. And I've already worked out the frequencies. So I've got 10, 38, 30 and 12. The next thing for me to do is to work out the fx, in which I just multiply these numbers together and it equals the fx values, in which I should end up with 1725 6840 5625 and 2340. Then from this, what I can then do is work out the total frequency, which is 100, work out the total fx, which is 16530. So then the estimated mean is going to be the total fx, which is 16530, divided by the total frequency, which is 100, giving me an answer of 165.3, which seems reasonable. Actually, no, it's not, because that is 90. Miscalculated. So let me just correct that, and then typing that all into my calculator, I should end up with a correct answer of 183.6 recurring, which definitely seems a lot more reasonable, because obviously I'm expecting an average to be in the modal group, which is 175 to 185. Next question, part C, then says that the tallest firefighter was 195.6, the shortest firefighter was 170.4. Both heights are given to one decimal place. Work out the maximum possible difference between the heights. So the max difference, so in terms of subtraction, is I want the biggest number, so the biggest, tallest person, take away the smallest, shortest person. So as it's to one decimal place, then this number to 1 dp, the maximum value it's going to be is 195.65. Take away, and then this number to smallest is going to be 170.35. So then if I type that all into my calculator, I should end up with an answer of 25.3. Moving on to question 11, it says that a small building company has 10 employees. The table shows their monthly salaries, and the first part says, what is the modal monthly salary? So here we're going for which one is the most popular. Well, it's going to be the labourer, which is £1,200. Then says the median monthly salary is £1,300. Explain why. So here, if we explain it by writing down all the numbers. So here I've got 5 people with 1,200. I've then got 3 people with 1,400. And 1 person with 2,500 and 1 person with 13,500. So here what I then want to do is work out the median value, and the median one is going to be in between here. So the median is 1,200 plus 1,400 divided by 2, which equals 1,300. The next one, part C, then says that the mean monthly salary is 2,620. Give a reason why the mean is not the best average to use for the 10 employees. And again, there's a couple of reasons which you could state that will get you the 1 mark for this. Is you could say something along the lines of, because the manager, or the manager's wage is much higher than everyone else's, or you could say compared to the others, or you could say that there is a big range or spread of salaries, or you could say that, and also you could also say that the median would be a better average. And if you're not too sure whether your answer will get you the mark, if you just have a look at the mark scheme, it should be able to tell you to use instead. So from that, let's have a look at question 12. It says 5 whole numbers are written in order. So here what we've got is we've then got 4, 7, x, y, and 11, and it says the mean and the median of the 5 numbers are the same. Work out the values of x and y. So looking at this, let's have a look at the median. Well, the median is going to be x. So the median equals x. Now, if you want to work out the mean, what we've got to do is add all these numbers up. So 4 plus 7 plus x plus y plus 11 divided by 5 has got to equal x. So then if I then simplify the top, I've got 4 plus 7 plus 11. So that's going to be 22 plus xy plus x plus y equals, and it's going to be 5x. And if I take the x over to the side, I end up with 22 plus y equals 4x. And from this, what I then got is 4x minus 22 equals y. So one variation of that. So what I've got to try and do is make sure one of these are true. Now I know that x and y has got to be a number between 7 and 11, and also that x has got to be smaller than y. So here the possible values of x is going to be 7, 8, 9, 10 and 11 it could be. So let's have a look at substituting these numbers in to see what it gives me for y. So using this, let's have a look. So x value, and then let's look at the y value. So when x is 7, well, 7 times 4 is 28, and 28 take away 22 gives me 6. So that's not going to work because y needs to be bigger than x. So when x is 8, then I get 4 times 8, which is 32, take away 22, which gives me 10. And that does work. So that means that x equals 8 and y equals 10. Moving on to question 13, it says, what does A union B represent in probability of A union B? And that basically is A or B. So it's going to be A or B or both. So it's that one there because it does include the both. Then with question 14, it says, which of these represents the shaded region? And basically it's going to be A or not B. So it's this value here. Then moving on to question 15, it says, what does this represent? And that represents A and B. Then for question 16, it says A and B are two events. Some probabilities are shown in the Venn diagram. Work out the probability of not A or B. Now for this, what we've got to do is we can work out what goes outside, which is 0.2. Now for this, what we need to do is we need to shade in the two individual bits. So if I shade in all the area that's not A, then basically what I'm shading in is this. So everything apart from the circle of A. So then the next one is B. So if I then shade in that area of B, well, that's all this bit here. Now when it's all, I want everything that has been shaded in. So here I've just got to add up all the bits that's shaded. So that's going to be 0.2 plus 0.15 plus 0.35, which gives me an answer of 0.7. Alternatively, what I could have done is 1 take away 0.3, and that would have also given me 0.7. Then moving on to our last question. So it says, which of these represents the shaded region? Well, that's going to be A and not B. So that's that one there. And for B, which of these represents the shaded region? And the correct answer is our first option, because it's everything apart from the two circles.